Hello and welcome. We look at arithmetic sequence. Okay, let's start by looking at this pattern for arithmetic sequences. We have a wall being built. In the first minute, we have 2 bricks ready. In the second minute, this is what happens in the next pattern. And then, by looking at this pattern, we can see what happens in the third minute. Okay. Now, in the fourth minute, as you can see, it carries on with the same pattern. Okay, can you guess what happens in the fifth minute? Pause the video and guess. I hope you got the right guess. In the fifth minute, it carries on with 2 more bricks, and we get this number of bricks on the wall. Okay, so let's look back to the pattern from the start. We ask a question now: which sequence of numbers best describe the progress of the pattern, which is the progress of the number of bricks on the wall? You have 3 sequences here, A, B, and C. Choose one of them that best describes the progress of the pattern. So it's sequence B. 2, 4, 6, 8, 10. That's the number of bricks each time. Okay. This type of sequences is called arithmetic sequence. These are sequences that progress with a constant difference. Okay, every number in the sequence is called term. 2 is the first term, 4 is the second term, 6 is the third term, and so on. What is the sixth term in the given sequence? So, to get the sixth term, we need to add 2, okay, because we need to add 2 to get the third term. We carry on with the same pattern. So each time we add 2. As you can see, 8 to 10 is 2. First, second, third, fourth, fifth. The sixth term is 10 plus 2, which is 12. Okay, 12 is the sixth term. Now, you have a practice. Which of these sequences is arithmetic? What is the sixth term for each arithmetic? Pause the video and try. Sequence A is not arithmetic because from -2 to 4 we add 6. Okay. And then from 4 to 6 we add 2. So it's not a common difference. Second one, add 4, then add 2 only. So it's not arithmetic. The last one, add 4 everywhere. So it's arithmetic. To get the next one, the fifth, we add 4, we get 16, and then we add another 4 to get 20 for the sixth term. Okay, now from these examples, we can go to give a general definition for an arithmetic sequence. It's a numerical pattern that increases or decreases at a constant difference. Look at the example. 0 is the first term, it increases by 4. This sequence increases by 4 from term to term. The second one increases by a difference of 2. Okay, so we call this a common difference. Okay, and usually the common difference, for example, in the first example 1 is 4. Okay, which is the difference between 2 consecutive terms. Like 12 minus 8 equals 4. The notation for this in general is D. So in the sequence, the first sequence, D is 4. In the second sequence, D is 2. Now, here's a practice for you. Pause the video and try to answer this question. To give the fourth term and the common difference for each arithmetic sequence. Here, the fourth term is 19. As you can see, is the fourth one in the list. And the common difference is 6. Okay, the second one, the fourth term is not given. We need to find the common difference, which is 80. And then we have to add 80 to 120 to get the next term. Okay, so the fourth term is 200. 80 plus 120. Last one, we add, we subtract 4. This is decreasing by 4. So the fourth term is -12. This is a summary of the answer. Now we go to the next part. Here's another practice. practice 3, how many times we add the common difference that you have to find to get the fourth term, the fifth term, the 100th term, and the nth term, a term of position n. Pause the video and try. Okay, the difference is 2 in this case. The fourth term is 7, so we add 3 times. 3 times, we add 2, 3 times to get to the fourth term. Okay, the difference is 2, the common difference, and we add it 3 times, as you can see. We add 1 more 2 to get to the fifth term. Okay, 1 more 2. So in total, how many times we add the 2? We add it 4 times to get to the fifth term. To get to the fifth term, we add 4 times 2. Now we go to the next part. How many times we add 2 to get to the 100th term? How many times we add 2 to get to 100th terms? Look at the pattern. Okay? So, to get to the second, we add 1 2. To get to the third, we got 2 2s. To get to the fourth, we add 3. To get to the fifth, we have to add 4 times 2. As you can see, the pattern is clear. To get to the fifth, we add 4, which is 5 minus 1. And the previous, 4 minus 1. Every time, we put the order minus 1. So it's 100 minus 1, which is 99. So we get 99 times 2 to get to the 100th term. Okay? And this is our term, 1 plus 2 times 99. We calculate, we get 199. And then we can get the formula for the nth term. Okay, so just take away 1, n minus 1 times. We add 2, n minus 1 times. Now, what is the nth term? It's 1 plus the number of times we add 2, which is 2 times n minus 1. Okay, this is our nth term. Let's go now to the formula. In general, if a is the first term and d is the common difference, a term in order n is given by the relation nth term equals first term plus n minus 1 times the difference. Usually we use a notation for the nth term a and index n. Okay, so a n is the nth term usually. So the formula becomes like this. Okay. That's it. That's for the nth term. So you have to use this formula. A is the first term. Okay, and d is the common difference, and n minus 1 and n is the order, the nth term, the order of the term, and so subtract 1 to get your n minus 1 times d. Now, here's an example. To get the nth term for the sequence 5, 12, 26, we can find the common difference, which is 7. 5 to 12 is 7. And 12 to 19 is 7, and 19 to 26 7. The common difference is 7. Then we substitute in the formula. D equals 7, and A equals the first term. So we use the formula as it is, and then we substitute A and D. That's all. A is 5, the first term, given in the question. And the common difference is 7, as we said before. Okay, substitute. So you get an equals 5 plus n minus 1 times 7. You can simplify this, multiply 7 over bracket, 7n minus 7, and then simplify to 7n minus 2. This is your formula for the nth term of this example, the sequence in this example. Thank you for watching, and see you soon.